Morning, I'm Maheswari, AP department. This video, we are going to discuss about the topic signal conditioning and data acquisition system. In that, we are going to refer what is signal conditioning and what are the functions of signal conditioning, necessity of signal conditioning, and the different types of signal conditioning. Okay, so first, what is signal conditioning? So in signal conditioning, it is the process of modifying the output signals from the transducer into a satisfactory form or satisfactory signal using the amplification, attenuation, and linearization, multiplication, or the other functions such as filtering. So, what we can understand from the signal conditioning is the signal conditioning. It is a device that used to modifies the analog output signals produced by the sensors and provides the essential circuit between the sensors and the data acquisition system. These modifications convert the various signals into signals that are compatible with process monitoring and control devices. For each specific signal, a signal conditioner serves as an interface to excite or to amplify or buffer the real world signals. So, the signal conditioner types differ by both physical value they measure as well as their specific features and the types of excitation. So now we have understood what is the signal conditioning. It is used to process or modify the output signals from the transducer into a form which is usable by the necessary applications. Now the necessity of signal conditioning. So the signals which are entering inside, the signals which are reaching the transducers that may be too noisy due to electromagnetic interference. The signals may be too small, so usually of millivolt range. So we have to amplify it. So low amplitude to high amplification value we have to change it. And the signals may be non-linear and they are required to be converted into digital form, converting non-linear into linear form. The signals may be an analog one and it is required to convert into a digital one, then we need signal conditioning. And sometimes the signal may be a digital one, we need to convert it into analog form, we need a signal conditioning. And in order to improve the quality of the digital signals, we need the signal conditions. So the different functions of signal conditionings are it is performing an amplification, modification, impedance matching, data processing, data transmission. So in this amplification means the enhancement of the signal level from the low level range. So the amplification system brings the level of the transducer signal to a value which is enough to make it useful for conversion, processing, indicating and recording. Modification or modulation means the change of the signal so, in a manner such that it is smoothed and linearized, filtered, or converted into digital form, all this comes under the modification. Impedance matching. So, in a signal, the equipments there is an arrangement between the input and the output impedance, which has to have a impedance matching. So, in order to prevent the loading effect of the transducer and to maintain a high signal level at the recorder end, we need this impedance matching. Data processing means the mathematical operations which is done before the recording of the data, the operations such as addition, subtraction, or any integration. So this is known as data processing. Data transferring means to transmit the signal from one location to another without changing the content of the information. So when this process has been done, the signal should have a proper selection of a component and it should have a proper reproduction of the signal should be maintained. Now we will move to the types of signal conditioning. So the signal conditioning according to the physical value measurement, they are classified into different types. First one is Temperature signal conditioner. So the temperature signal conditioner, it is compatible with the sensor that measure temperature or vibrations in temperature. The temperature signal conditionings are used to amplify the analog signals produced by the sensors to filter out noise and push the signals forward for analysis and display. And then thermocouple. The thermocouple used in applications, many applications. The thermocouple, the output range is plus or minus millivolt range, which is low output voltage. It is difficult to process or monitoring these values. The temperature signal conditioners amplify these signals. The temperature signal conditions performs linearization of the analog signal, whether the output voltage of thermocouple is linear with respect to temperature. And then thermistor is used as a temperature sensor in different industrial applications. So thermistors are temperature sensors which requires current and voltage excitations. So the temperature signal conditioners provides amplification and low pass filtering for thermistors, performing these operations to modify the signal so that they can easily read by the digital devices in the data acquisition system. And RTD, that is the resistance temperature devices or temperature sensor that use variation resistance to calculate the temperature. So RTD signal conditioning or eliminates the unwanted signals from the line resistance, non-linearity and self-healing. Pressure sensor signal conditioner. Pressure sensor signal conditioner, it senses the pressure value. The pressure sensors works by monitoring the strain or stress experienced by any bridge. So the output of the pressure sensors varies in millivolts. So the pressure sensor signal conditioner eliminates the common mode signals with high retaining pressure variation values. And then load or strain signal conditioner. The load cells or strain gauge measures the force on a device. It can be either a tension or compression. So the load cell along with strain gauge requires excitation voltage range of 2.5 to 10 volts and is achieved using a signal conditioner. An LVDT signal conditioner, linear variable differential transformer, it measures the position of the object and then the signal is sent by the signal conditioner. It is easy to recognize the digital reading devices within the data acquisition system. The output of this LVDT is passed through the low pass filter to ensure that the noise levels are kept to a minimum. And then torque signal conditioner. Here the load and the pressure signal conditioner, it can produce low or high output voltage based on the excitation voltage of the sensor. AC and DC signal conditioner. Signal conditioning is referred for either to convert or amplify the DC current or voltage signal, and it is used to reject the noise signal, which is done by filtering the input. AC signal conditioner, it is used to here it is used to accept the AC current or voltage signal and then convert into DC current or voltage signal. And then frequency signal conditioner, the different sensors that produce frequency outputs are converted to a usable analog DC signal that is measured with a measurement device. So this is about the types of signal conditioner according to the physical value measurement. And now the types of signal conditioning depending upon the excitation source, that is the DC signal conditioning and AC signal conditioning. So first you will see what is DC conditioning systems. So in a DC signal conditioner, here the device converts the DC input signal into a DC output signal and it is proportional to the galvanic isolator from the input signal. So in this DC conditioning systems, the DC systems are mainly used in potentiometers and resistance strain gauges, and this is the block diagram of the DC signal conditionings. Here in this block diagram, say for example, the resistance like strain gauge constitute one or more arm of a Wheatstone bridge which is excited by an isolated DC source. The bridge can be balanced by a potentiometer and also can be calibrated by an unbalanced conditions. So in this, we are using an measurement devices, that is the measurement, which is given to a transducer, and the bridge, it is used as a balancing bridge which is supplied with an DC excitation source. The output of the bridge is given to the calibration network and it is amplified using a DC amplifier, and then power supply is provided to this DC amplifier, and after providing a filter it is given as output. So the characteristics of this DC signal conditioning, it should be it should have a good thermal and long-term stability. It may require balanced or differential inputs. The CMRR is a measure of ratio of desired signal to undesired signal. This value should be as high as possible. And the advantages of it, the DC amplifier is easy to calibrate at low frequency and is able to recover from the overload conditions. And the disadvantages regarding this DC signal conditioning system, the DC amplifier is followed by a low pass filter which eliminates the high frequency component or noise from the data signals. The applications of this DC amplifier is, the DC system is used in transducers such as potentiometer and resistance strain gauges. Thank you everyone.